Hello mathematicians, I hope by the end of this video you can say I can solve and graph compound inequalities. A compound inequality is a statement that consists of at least two distinct inequalities that are joined together by the word and or the word or. So let's look at a couple just basic examples of that now. So intersection is what we call the and inequalities. So we get x is greater than or equal to -1 and x is less than 4. So what we're going to do is we're going to graph these two inequalities individually on a number line. So we see x is greater than or equal to -1. So this is -1 right here. We'll fill it in because it is greater than or equal to. And we are going to move to the right over here. Okay, and now let's graph the other one on a number line. So we find 4 on the number line, and that's right here, and we fill it in because it is less than or equal to 4. And we are going to move to the left here now. Okay, and because it says and, so this is going to be the intersection of these two graphs. So if we were to draw a line down right here between these two, we'd see where these two graphs intersect is this area right here in between. So our graph of this intersection would look something like this. Find -1, which is right here. And we'd fill it in, and we'd find 4, and we'd fill it in. And it's going to be all the values in between right here. So that would be how we would graph this inequality right here, represented by x is greater than -1 and x is less than 4. So it's the intersection of those two. And if we were to write this in interval notation, we could say right here we go from -1 to 4 with our square brackets because we're including both of the endpoints right there. Another way we can notate this is -1 is less than or equal to x is less than or equal to 4. So these are all ways of notating this right here. So you might also see this graph look something like this, or this interval represented something like this. Another example of a compound inequality that I think will be a little bit less common, but I figured I would include an example of it anyhow, is say we're to have this intersection right here of x is greater than 0 and x is greater than or equal to -3. So we would draw each of these on their own individual number line. So let's do that right here. So we have x is greater than 0. So we'll put that right here. And we're going to leave it open because it's just greater than, not greater than or equal to. And we're moving to the right. So that would be this one right here. Now let's draw this one on another number line. And x is greater than or equal to -3. So we find -3, fill it in, and we're moving to the right again. And now we see that the intersection of these two graphs is going to be this point and everything over. So the graph of this intersection of x is greater than 0 and x is greater than or equal to -3 would look like this. So we find 0, and we're going to fill that or leave that open, and we're moving to the right and right here. So that's what this graph would look like. One last example of intersection is we have the statement x is greater than 2 and x is less than -4. So we'll graph x is greater than 2. So we find 2 on our number line, and it's greater than 2, so we're moving to the right. And now let's graph x is less than -4. So we find -4 on the number line, and we're moving to the left because it is less than. And we see that there is no intersection between these. There is no intersection between these two graphs. So our answer to this would be no solution. This graph would have no solution, which makes sense. There's no value that is greater than 2 but less than -4. So that would make sense. Okay, so that's some examples of intersection. So now we're going to look at union, which is our or statements here. So we have x is less than -2 or x is less than or equal to -1. So let's look at these two on their own separate number lines here. So we find -2 on our number line, and x is less than -2, so we're moving to the left. And now let's look at x is less than or equal to -1. So we find -1 on our number line, and we're going to fill this in, and we're moving to the left because it's less than or equal to. Okay, so what union means is that we're looking for our inequality that satisfies at least one of these two inequalities. So we're not looking for overlap, we're just looking for the one that includes these points. So the union of this graph would look like this. So we'd find -1 and we'd fill it in, and we're going to move it to the left. Because this graph right here, this would be our union, okay, of these two graphs right here. Because this one satisfies at least one of these two statements right here. And this one, so our answer would be It'd be from negative infinity, all right, to negative 1 in interval notation. So another example of union would be x is greater than 0 or x is less than 2. So let's look at these on their individual number lines. We're looking at x is greater than 0, so we'd go right here, and we're moving to the right. Now let's look at x is less than 2 on the number line. So we would find 2. We know x is less than 2, so we're moving to the left. So we see the number that, or the solutions that satisfy one of these two inequalities would look like something like this. It would be all real numbers, okay? Because that would satisfy, because we know it's everything to the left of this and everything to the right of this. So our answer would be all real numbers in this situation. So one last quick example of union. So we got x is less than or equal to 7 or x is greater than 9. So let's look at these on their individual number lines. So x is less than or equal to 7. So we find 7, fill it in, and we're moving to the left. And now let's look at x is greater than 9. So we find 9 on our number line, and we're moving to the right. So the graph that would be for the union of these two would look something like this. So we'd find 7 and we'd fill it in, and we're moving to the left, and then we'd find 9 and we'd leave it open, and we are moving to the right. Okay, so that would be the graph of this union right here. So that's just some basics on compound inequalities. I hope by watching this video and with a little bit of practice, you can say, I can solve and graph compound inequalities.